So in this video, we are going to discuss Worksheet B number 13, part C. It says use the results in part C, the previous part that we did, part C1, to determine the gradient and the y-intercept of the equation of the line of best fit, linear regression, and write the equation in the form score is equal to m times hours plus C. Now to do that, let us go to weekly notes number 7. So we are now in weekly notes number 7. As you can see, the values for correlation is between -1 and 1 inclusive. Okay, so we have to take that into consideration. So here we've got the steps for the product moment correlation and coefficient of determination. Now weekly notes 8 will be on regression. According to weekly notes 8, which is linear regression, it says in a nutshell, linear regression is concerned with the modeling of a linear equation y is equal to mx plus c that can be used to predict or forecast future values. This course is concerned primarily with two methods in which this can be done: least squares geometrically and via the scatter plot. So the equation of a straight line has the standard form y is equal to mx plus c, where x and y are the related values. X is the independent variable, y is the dependent variable, m is the gradient of the line, and c is the y-intercept. So the steps to obtain the linear equation via least squares: first, we have to calculate the gradient using the formula m is equal to n times the sum of xy minus the sum of x times the sum of y over n times the sum of x squared minus the sum of x all squared. Now, when we look closely at this formula, we realize that the numerator is identical to the product moment formula, which we call A, and the denominator is identical to that of 3 and 4, 3 minus 4, which we call B. So the gradient simplifies to A over B. Remember, we calculated A to be 150 and we calculated B to be 150. So the gradient is actually 150 divided by 150, which is 1. As you can see, the gradient m is equal to 1. Now the y-intercept c is equal to the sum of y minus m times the sum of x over n. Now we've got to go back to our calculations to find the sum of y and the sum of x. We found the sum of x to be 45 and the sum of y to be 150. And we got m to be 1. And n is 3, the number of pairs. So the y-intercept c is equal to the sum of y, which is 150, take away m, which is 1, times the sum of x, which is 45, divided by 3. Minus 1 times 45 is minus 45 over 3. So we have 150 minus 45 is 105 divided by 3. What's 105 divided by 3? 35. And as stated, 105 divided by 3 is 35. So now we have calculated the gradient, we have calculated the y-intercept. So now we can write the equation. Y is equal to mx, which is 1x plus c, which is 35. Now we've got to write this in the form of score and hours. Y is hours and x is score. No. Y is score and x is hours. X is the independent variable, so hours is the independent variable. Score is the dependent variable, so score will take the position of y. So the formula is specialized by saying score is equal to hours plus 35. And you can use this model to calculate score if you've got hours and to calculate hours if you've got score.